everyone, this is your summary of logs and indices, two very important topics. Now, the good news about logs and indices is that you have pretty much all the rules you'll ever need on page 21 of your log tables. So keep page 21 open when no other page is open. Go back to page 21 because it has so many of the key formulas that you'll need. The one thing to be aware of with page 21 is that the rules in practice will never appear exactly as they appear on page 21. Like you'll never see a to the p times a to the q, But that is why you need to be able to talk yourself through these rules. The goal here is to get these in your own words so that then you can spot when to use these rules in any context. And you don't necessarily need to remember these rules because you have them on page 21. I think you will by the time you're done. But you need to be able to spot when you need to use them. Okay, so first one there, top left hand corner here, it's the top left hand corner, page 21. A to the p times a to the q is a to the p plus q. So to talk yourself through it in your own words, what we have here is the same base. A is the base, you are multiplying, and what you do is you add your powers. Okay, and the other thing about this is that we need to be able to go both directions with this rule. So we need to be able to go from here to here, but also to go backwards. So I think we're pretty good going forward. So for example, if you saw 2 to the x times 2 to the power 7, I think we'd say that's 2 to the power of x plus 7. We might not be quite as good at taking this and expressing it this way. But with all these rules, there tends to be one direction that we're quite good at and another direction we don't do as often. So I want you to be aware of that fact that if it works in one direction, it works in the opposite direction as well. So if you see addition in the power, that means you can break it apart and multiply your bases. And then we just check back by, checking do the powers add to x plus 7. Okay, rule 2 very much mirrors rule 1, only it deals with dividing. So when you have a to the p over a to the q, a to the p minus q. So what you see here is the same base, a, you're dividing and you subtract your powers. So for example, if you had 5 to the power of 3 minus x, this is working backwards now actually, just to note, you could write that as 5 to the power of 3 over 5 to the power of x, and if in doubt, check, is this equal to this? And it is. Okay, the third rule is the nested powers. I call it the nested powers rule because you have a to a power to a power. So if you have a to a power to another power to any number of powers, you multiply your powers. And that's what you do. So for example, here, e to the x to the power of 3 is e to the 3x, multiplying the powers. Now this is a very important one because this appears in quadratics in exponentials. So if you see 5 to the 2x, that could be written as 5 to the x all squared because 2 times x will give you 2x. So if you spot that in the middle of an equation like a 5 to the 2x and then there's maybe a 5 to the x term and maybe a number or something like that, that could be 5 to the x all squared plus 5 to the x plus 7, and there's a quadratic in 5 to the x. So that's when you need to spot that 5 to the 2x is actually 5 to the x squared. Okay, on to the fourth rule, moving down here, on to the fourth rule, and still on page 21 of your log tables, a to the power of 0 is 1. That basically says any number to the power of 0 is 1, doesn't matter what the base is, to the power of 0 is 1. Then the fifth rule is a to the minus p is 1 over a to the p, and vice versa, a to the p is 1 over a to the minus p. So to talk yourself through that, when you are bringing a term below or above the dividing line, you must change the sign of the power, okay? So for example, if you saw something like x cubed times y to the power of minus 4 all over z to the power of minus 2, okay? That breaks down into x cubed times y to the power of minus 4 times 1 over z to the power of minus 2. And then if you wanted to make all your powers positive, which we tend to want to do, that's x cubed. This is 1 over y to the power of 4. And when we bring the z to the minus 2 up, we get z squared. You could write that over 1 if you like, and combining again, x cubed z squared all over y to the power of 4. Okay, so you could have jumped straight away and said that comes up and that comes down and leave the x cubed as it is. But just remember, you do a lot of that when you're integrating and differentiating. When you see 1 over x squared, it's easier to think of it as x to the power of minus 2 when integrating or differentiating. Oh, I have an example over there. Okay. And then 6 and 7, these are your roots. Still on page 21 of your log tables. So we know the cube root of a is a to the 1/3. So the roots have fractional powers. Basically, that's what this is saying, okay? This one you must remember. So the square root It's like the little 2 is missing there. We don't tend to write the 2. The square root is a power of a half. The amount of mistakes I've heard there with regard to the square root, been called all kinds of different powers. It's the power of a half. That's why I have it emphasized there. Must remember this. And then combining 3 and 6, we get this. So a to the p over q is this. So that's, we don't use it all that often, but it's good to know. And then 8 and 9, the last 2 on page 21. So this is different from the first 2. These are different because here, notice how you have the same power this time rather than the same base. So if you have the same power and you're multiplying, what you do is you multiply the bases. Okay, so take this example here. We have x times y squared to the power of 5. So the power of 5 goes on x, it also goes on y squared using this rule forward there. And then y squared to the power of 5 is y to the power of 10. A very important application of this rule is the square root. The conclusion here is that the square root of AB is the square root of A times the square root of B. How you get there is through this rule, because the square root of AB we know is a power of a half. We know we can distribute the power across the product there, a times b to a to the half and b to the half, which is the square root of a times the square root of b. Remember that as well. I think that's a handy one to remember, because I think students hesitate because you know that this is not equal to this, and then you kind of hesitate and wonder, well, is this square root of x times y equal to the square root of x times the square root of y? It is. And then the final rule is the division equivalent. So you have the same power, you divide the bases, which gives us this fact: square root of x over y equal to the square root of x over the square root of y. Okay, so moving on to logs. Now I'm just going to move one of these down slightly. So we get to keep an eye on, there we are, yeah, okay. Just on the right hand side there, to start off, a few kind of the important facts that are easier to explain perhaps. ln x is the natural log of x. So natural log is log base e. That's something you need to know, okay? Now I am in the middle column of page 21 in the log tables. And I'll start over here on the left hand side. So rule number 1 in the middle column, log base a, so this works for any base, x times y is log base a of x plus log base a of y. Okay, how you talk yourself through this is, if you're multiplying on the inside of a log, see the multiplication on the inside? It turns into addition on the outside. So log of something times something turns into log plus log. So for example here, log of 3x plus 6, I can factor out a 3. There is multiplication on the inside, which turns into addition on the outside. And something to remember is that log of a number can go straight into your calculator. So log number goes straight into your calculator. Sometimes that can be off-putting and you think, oh, this is another variable or something. No, it can just go straight into your calculator. Okay, if you get number 1, number 2 isn't the worst, so it is the division equivalent. So log of x over y is log of x minus the log of y, works for any base. And what you see here is you're dividing on the inside. That turns into subtraction on the outside, and there is an example. Okay, so multiplying on the inside turns into addition on the outside, dividing on the inside turns into subtraction on the outside. And then the third one, this is the one with the powers. It's very important. We use this an awful lot. So log base a of x to the q is q log base a of x. See my arrows there? The q can come out in front basically, or the number from in front can come up as a power. Be careful though, be very careful. This is a very important little note here. This is not equal to this. So see log base a, 5 times x squared. You can't take that 2 out in front because the 5 is not raised to the power of 2. Okay, it's 5 to the power of 1 times x to the power of 2. So how you deal with that is break it apart with the addition rule. Okay, so that's log base a of 5 plus log base a of x squared. And then that 2 can come in front. So that's something to be very careful of. It has to be log base a of whatever you have inside the bracket to the power of q. Then the q can come out in front. Okay, so in the middle column there, you have rules 1, 2, 3, 4, 4, and 5. Okay, so there's 4. Log base a of 1 is 0. So basically, the log with any base of 1 is always 0. And then log base a of 1 over x, that actually comes from, you get this result from using the previous rules. So yeah, we don't use number 5 quite as often because we tend to use the previous rules, you know. And one thing to note actually here, one of the many things to note, on page 21, there is no rule with log base a of x plus y or log base a of x minus y. Just notice that. There's no rule that will help you unpack log base a when you're adding on the inside. So when you see something like this, you might think, oh, there must be a rule that can, that'll allow me to simplify this. There isn't, and it's good to know that there isn't any, okay? And then finally, very important one here about the logs to exponentials. So this is just a restatement of the same equation. If you take this equation, it can be restated as this. So a to the power of x equals y is the same as saying log base a of y equals x. So how I get from one to the other, I find it easier to go from the log to the exponential by taking the base and kind of going in a circle. A to the x is equal to y, that gives you this. So this is like saying, x squared is 17. An equivalent equation is x is plus or minus the square root of 17. It's just a rewriting of an equation. It just is a quite convoluted rewriting of an equation. So this is the log to exponential. And when do you use this? If the x is in the power, if there's an unknown in the power, then you rewrite the exponential equation, I'm missing a word there, as a log equation. So 5 to the x equals 7. If you see an unknown in the power, just be aware that at some point you're going to have to use logs. So log base 5 of 7, that works because 5 to the x equals 7 is the equivalent exponential equation. That can go straight into your calculator and gives you a solution after tidying up, after cutting out a few decimal places. And then if the x is inside the log, then you would go to the exponential equation to find x. So there's an example, and a log base 2 of x plus log. So log plus log, we know we can rewrite by multiplying the inside. And then when you're at that ninth stage of log something equals number, that's when you can use your circle and say 2 to the power of 4 is equal to x times x minus 6. And just be careful with the log equation. When we solved the quadratic here, we ended up with 2 solutions, but something to be very careful of. Log of 0 and log of a negative number are not defined. So we can't include not defined. So we can't include minus 2 here as a solution, because if you plug back in minus 2, we end up with the log of minus 2 or the log of minus 8, and it's not defined. So your answer is only x equals 8. So just be careful of that. It's like when you have a square root in an equation. You have to check that your answer doesn't result in something negative under the square root. Okay.